Hi and Assalamualaikum. My name is Nurshida Shazwina. In this video, we will be presenting our findings from experiment 4, which is reactions of aliphatic alcohols. First, let's talk about what aliphatic alcohols are. Aliphatic alcohols are organic compounds that contain a hydroxyl group which written as OH attached to a carbon chain. This alcohol can be classified into three types based on where the OH group is bonded. The first type is primary alcohol, where the OH group is attached to a carbon bonded to only one other carbon. For example, ethanol. The second type is secondary alcohol, where the OH group is on a carbon bonded to two other carbons. For example, butan-2-ol. The last type is tertiary alcohol, where the OH is on a carbon bonded to three other carbons, such as 2-methyl-propan-2-ol. Moving on to our objective. The purpose of this experiment is to investigate the reactions of aliphatic alcohols with certain reagent. Specifically, we carry out 4 tests. The first one, reaction with sodium metal, esterification, oxidation using potassium dichromate, and the Lucas test to identify alcohol types. This is all the chemicals and apparatus that we use in our experiment.
First, 1 ml of ethanol was transferred into a dry tube test. Then, a small piece of sodium metal was added carefully into the tube test. The tube test was closed with a stopper and gas was released when tested using a burning wooden spoon. Finally, the observation was recorded. First 2 ml of ethanol and 2 ml of tertiary acid were transferred into a clean boiling point. Next, 2 ml of concentrated sulfuric acid was added carefully. The mixture was shaken gently and heated in the bathwater for 5 minutes. After heating, it was allowed to cool to room temperature. Then the reaction mixture was poured into 5 ml of sodium carbonate solution prepared in a evaporated dish. Lastly, the smell of the product was recorded. First, for this one, first 1 ml of ethanol was transferred into a boiling point. Then 1 ml of dilute sulfuric acid and 0.5 ml of potassium dichromate solution were added. The mixture was heated in a bathwater and the physical changes were observed and recorded. First, 3 clean tubes was prepared. About 1 ml of butanol, butan-2-ol and 2-methyl-propan-2-ol were added into a first, second and third tubes respectively. Then 3 ml of Lucas reagent was added simultaneously to each test tube. Then the test tube was closed and with stopper, shaken well, and left to stand for 5 minutes. Finally, the observation was recorded.
Now I will explain all of the results we obtained from our experiments. For our first test, we added ethanol with sodium metal. We observed bubbles forming along with an audible pop sound, confirming the production of hydrogen gas. The reaction produced sodium ethoxide and hydrogen gas as shown in the equation. Next, we carried out an esterification reaction between acetic acid and ethanol. The product was a colorless solution with a strong irritating smell. Characteristics of the ester ethyl acetate form, along with water as a byproduct. In the oxidation test, we used an orange oxidizing solution, which turned blue as the alcohol was oxidized. We also noticed a banana-like smell, suggesting formation of an ester or aldehyde product. Shown here is the structure of acetaldehyde, the oxidation product. Moving to the Lucas test, which helps us distinguish between primary, secondary, and tertiary alcohols based on reaction rate with HCl and zinc chloride. Starting with butanol, a primary alcohol, we observe no reaction. No cloudiness appeared, consistent with primary alcohols reacting very slowly. Testing butan-2-ol, a secondary alcohol, we again saw no immediate reaction. Secondary alcohols typically take longer to react and form a cloudy layer only after several minutes of warming. Finally, with 2-methyl-propan-2-ol, a tertiary alcohol, the solution turned cloudy immediately. This rapid reaction confirms it's a tertiary alcohol, Since tertiary alcohols react fastest with the Lucas reagent due to the stability of the carbocation intermediate form.
Assalamualaikum. For the next part, I'm going to talk about discussion. In the experiment, the reaction of aliphatic alcohol with several reagents were investigated to study their chemical properties and reactivity. The observation that we obtained showed clear differences between primary, secondary, and tertiary alcohols. For the reaction between ethanol and sodium metal, effervescence was obtained and a pop sound was produced when the released gas was tested with a burning wooden splinter. Ethanol reacted with sodium to form sodium ethoxide and hydrogen gas. This experiment showed that alcohol possesses weak acidic properties due to the presence of the hydroxyl group. Next, the Lucas test was carried out to differentiate the type of alcohols based on their reactivity with Lucas reagent. Different rates of turbidity and cloudiness formation were observed for each alcohols. First of all, butanol showed no visible changes within 5 minutes because primary alcohols react very slowly at room temperature. Second, butan-2-ol become cloudy after a short period of time, indicating a moderate reaction rate similar and typical of secondary alcohols. Meanwhile, 2-methylpropan-2-ol turn cloudy almost immediately because tertiary alcohols react very quickly due to the formation of a stable tertiary carbocation intermediate.
In conclusion, the experiment successfully demonstrated the chemical reactions of aliphatic alcohols, particularly ethanol. When reacted with sodium metal, ethanol produced hydrogen gas, showing that it has a weakly acidic hydroxyl group. Overall, the results show that aliphatic alcohols can undergo reactions such as oxidation, acidification, and reaction with active metals, and their reactivity depends on their molecular structure.